In this tutorial, you will learn how to solve for angles in a right-angled triangle by knowing the two sides of a right-angled triangle. I have an isosceles triangle A, B, and C. An isosceles triangle has two equal sides, and the base angles in the isosceles triangles are equal. The two base angles here. Drawing a line from the center of an isosceles triangle perpendicular to this baseline gives two right-angled triangle ADB and ADC. Both triangles right-angled at D. Now, we have a question which says the sides of an isosceles triangle is given as this. We have the sides of an isosceles triangle are 7 centimeters, 6 centimeters, and 7 centimeters. I said isosceles triangle has two equal sides. So this says 7 centimeters, which actually has to be the longest sides of the triangle, has to be to this side. We have 7 centimeters and 7 centimeters. Then the base length, BC here, is from here to here, is 6 centimeters. Now, we are asked to find the base angle to the nearest angle. That will be any of these angles. Now, if we are solving for an angle in any triangle, we need at least two known sides to be able to solve for an angle. Now, we have this side known, we have this side known. We want to use one of these right angles, triangle, to find either of this angle or this angle. The length of line BC is 6 centimeters. Drawing a line perpendicular to this BC divides this line into two at D, which means that line BD will be equal to line DC, which will be equal to BC, line BC all over 2, which is 6 centimeters over 2, and that gives us 3 centimeters, which means that from here to here is 3 centimeters, same way from here to here is 3 centimeters. Now we have two sides now. Picking this triangle ADB, or we'll say ABD, because we are looking for this angle. Let's call it theta. The side facing this theta is called opposite. The longest side of the triangle is the hypotenuse, while the side next to the angle is called the adjacent. Now, going back to our mnemonics, so, ka, tua, let's look for one of these trig ratios that captures the two sides that we know. We know the adjacent and we also know the hypotenuse, which means that we will be using her cosine to find the angle. So which means cos theta, which equals to adjacent over hypotenuse, will be equal to adjacent in this case is 3 centimeters and the hypotenuse is 7 centimeters. So cos theta equals to 3 centimeters over 7 centimeters. Our cos theta will be equal to 3 divided by 7 gives us 0.4286. Now, how do we find theta? Cos theta will be the arc cos. That's the inverse of the sine, of cosine, of 0.4286. How do we get that? You can use your trig table, or we use a scientific calculator. I have a basic scientific calculator here, and that's what I'm going to be using. So make sure anytime you are using a calculator, a scientific calculator, that it is in degrees. So I'm looking for the inverse. We have the inverse ratios here. Some calculators already have it stated, so you don't need to press your inverse. So I press the number 0.4286. I'll press arc cos, and that's 64.6212. 64. So theta equals to 64 plus 6212. The question says to the nearest degree. So my theta, by rounding up in this case, because the next number after this is greater than 5, will be 65 degrees. And that's the value of the theta here. Because this is 65 degrees, this also will be 65 degrees because the base angles of isosceles triangles are equal.